Black holes represent one of the deepest and most fascinating mysteries of the cosmos. These ultra-compact objects, capable of swallowing light, matter, and even space and time, are at the center of countless scientific theories, philosophical speculations, and heated debates. Despite the immense progress in understanding the universe, many questions about them remain unanswered. What's inside a black hole? What happens beyond their elusive event horizon? And most importantly, what can we learn from these gravitational enigmas that dominate the hearts of galaxies? In this video, we will attempt to answer these questions by exploring the darkest side, literally and figuratively, of the known universe. If you're passionate about space, science, and cosmic mysteries, subscribe to our channel and don't forget to hit the notification bell. The dark allure of black holes, at the boundary between science and science fiction. Black holes are not just cosmic objects. They are actual windows into a new physics, natural laboratories where the laws of nature are pushed to their limits. When we talk about black holes, we enter a realm where everyday concepts like space, time, and even reality seem to blur, giving rise to paradoxes and phenomena that challenge our understanding. The term black hole itself evokes an eerie image, a region of space where the gravitational force is so intense that nothing, not even light, can escape it. This creates an area of absolute darkness, a shadow in the very fabric of the cosmos, invisible to our eyes and ordinary telescopes. But what makes black holes even more fascinating is the fact that they aren't simply objects that suck in everything. They're far more complex than that. From a distance, a black hole behaves like any other massive celestial body. It exerts a gravitational pull on surrounding objects, warps space, and alters the flow of time. It's only when approaching the event horizon, the infamous point of no return, that things start to get truly strange. The event horizon, the gateway to the unknown. The event horizon is the threshold that defines the boundary of the black hole. Once something crosses it, there's no turning back. But what does it really mean to cross the event horizon? It's an experience as theoretical as it is fascinating. Imagine you're an unfortunate or extremely brave astronaut getting too close to a black hole. As you approach the event horizon, you would begin to notice something strange. To an outside observer, you would appear to slow down more and more, as if time itself were stretching out. This effect, known as gravitational time dilation, is caused by the black hole's intense gravity, which distorts the flow of time. From the outside, you would seem to freeze right on the edge of the event horizon. But to you, everything would proceed normally, at least until tidal forces began to take hold. Spaghettification, a grim fate. If you continued toward the black hole, you would be doomed to a bizarre fate. Spaghettification. This term has become almost legendary among scientists and physics enthusiasts, and refers to the fact that, as you get closer to the singularity, the difference in gravity between your feet and your head would increase dramatically. The tidal forces, the variation in gravitational force across your body, would stretch you into a long string, like a cosmic spaghetti, before completely tearing you apart. This happens because the gravity of a black hole is so powerful and localized that it elongates everything that gets too close, breaking molecular and atomic bonds. The singularity, the dark heart of the black hole. But what lies at the center of the black hole? According to general relativity, the answer is a singularity. A singularity is a point where density becomes infinite, and time and space cease to have meaning as we know them. It's a place where all physical laws break down. Anything that reaches the singularity, whether matter or light, is destined to be compressed into an infinitely small volume, erasing all traces of what it once was. Some scientists liken this phenomenon to an end of physics, a point beyond which our current theories can no longer describe reality. However, the singularity remains a hypothetical and mysterious concept. We don't exactly know what happens on a quantum level inside it, as our classical physical laws can't explain the extreme conditions that occur there. The search for a theory of quantum gravity, a fusion of quantum mechanics and general relativity, is one of the greatest challenges in modern physics. It's possible that once this theory is found, we may unlock the secrets hidden within the singularity. Black holes and information, the battle of modern physics. One of the biggest problems posed by black holes concerns what happens to information. In classical physics, information should never be lost. Even if we burned an object, the amount of energy and information it represents would still be conserved, albeit in different forms. But when something enters a black hole, it seems that all information about it is lost forever. This phenomenon is known as the black hole information paradox and is one of the most debated topics in theoretical physics. Some theories suggest that information might be preserved on the event horizon itself, in the form of entropy or as a hologram, an idea stemming from the so-called holographic theory. This theory proposes that three-dimensional information within a volume of space can be represented on a two-dimensional surface, much like images on a hologram. In this case, the information inside a black hole could be encoded on the event horizon, turning it into a sort of cosmic memory that retains every trace of what has been swallowed. Time travel and parallel universes, extreme speculations. Beyond the most rigorous theoretical physics, there are also some more extreme speculations about what might happen inside a black hole. Some physicists have hypothesized that a black hole could serve as a passage to another universe or to another part of our own universe through a wormhole, a kind of space-time shortcut. Though highly speculative, this idea has fueled the imagination of science fiction writers and scientists for decades. Another interesting hypothesis is that of white holes, the opposite of black holes. While black holes devour everything around them, white holes would constantly expel matter. Some scientists theorize that black holes and white holes could be connected by wormholes, and that the material that enters a black hole might emerge from a white hole in another part of the universe or even in another universe. The Big Bang, a white hole in action? Perhaps the most fascinating idea of all is one that links white holes to the Big Bang itself. Some physicists have speculated that the Big Bang may have been, in fact, a white hole, a burst of matter and energy from an infinitely dense and hot point. If this were the case, the beginning of our universe could be seen as the emergence of matter from a singularity similar to the one found at the center of black holes. This raises the mind-bending possibility that each universe may be born from a black hole, and that the black holes in our universe could generate new universes. Conclusion: black holes, a gateway to new frontiers. In the end, black holes remain one of the greatest and most fascinating enigmas of modern astronomy. Each new discovery about them brings us a little closer to understanding the very structure of the universe and the laws that govern it. But at the same time, they always raise new questions, pushing us to explore further and reconsider everything we think we know about reality. If this journey through the mysteries of black holes has intrigued you, keep following us to learn more about these and other extraordinary cosmic phenomena. Thank you for joining us, and until the next adventure in the cosmos.